Hi and welcome back guys to a new scripting tutorial. Today I'm going to show you how to make a really smooth and reactive player movement in 2D Godot engine. So as you can see, it's really smooth. It avoids using a really bad technique that I previously used, that was teleporting the player to the position of the mouse. Now um, the player is moving towards the mouse and not teleporting to the mouse, and it's really smooth. As you can see, it works in all resolutions and it's really great. It's simple as making pie what you want. It's just that. It's really simple. It's the advantage of Godot. So if you want to know how to do it, let's get right into it. So first you're going to create a new scene, like right here, and you're going to create a Node 2D. Sorry if my software is in French. I forgot to put it in English. So a Node 2D. Then a kinematic body 2D. I'm going to rename it as player, and then you put a sprite in it. You're going to use this little icon while selecting player, so when you're moving the sprite, it's not moving the sprite but the player. So you want to put a texture on your player. You can take the little Godot engine logo, and as you can see, it's also moving the player as I'm moving the sprite, so it's really important, or else it will, oops, it will do that and the player won't move. It's just the texture of the player that's going to move. So you're going to attach a script like with this little icon right here, JavaScript. So I'm not going to make the script from the start because I'm not used to do that. So I'm just going to explain what the script does step by step. So as you can see, I spaced all the functions. So it extends from the kinematic body 2D. That's kind of logical. So the motion, you're going to create a variable that's called motion, and it's a vector 2. So a vector 2, for those don't know, it's a variable that contains x and y axis, as you can see, so right here. And we are going to store the position of the mouse in it, as you can see. So post x is going to be the x position of the mouse on the x-axis. Same for pos y, but for the y-axis. Motion x is for the final motion on the x-axis that we are going to apply on the player. Same for y, but on the y-axis. And final pose is a vector 2, and it's the final motion that we're going to apply to the player, and it's going to be motion x and motion y. So it's kind of not logical, so I'm going to make final motion right here. So we're going to take the next part of the script. So when there's an input event, we're going to check if it's a mouse input, And then we're just going to say that motion is equal to the event dot position. So it sets the motion to the position of the mouse. So we're going to go and grab the core of this little script. So as you can see, oh yeah, I have to modify that. So as you can see, we're just going to use the function process delta. So it's going to be from the time and not the frame that's on the computer. It's really from the time. So every time we check and we say the pos x is equal to the position of the mouse on the x-axis, and position y is equal to the position of the mouse on the y-axis. So really the core of this is we're going to say if the position of the mouse minus the position of the player, so position.x, position is the position of the parent of the script. So you can use it in other scripts on the x-axis. If it is smaller than 0, we say that motion x equals minus 100 by ABS position x minus position x divided by 20. It seems kind of complicated, but it's really not if you try to understand. So we apply a force of minus 100 for the final motion, but in order for it to be really smooth, like in the example, the more it's closer to the mouse, it decelerates. So in order to do that, we're going to multiply it by the position of the mouse minus the position of the object. So when it's going to be closer, the variable is going to be smaller and the force applied to the object is smaller. And I divide it by 20, or else it's extremely fast. If I remove it, you're going to see it's really fast, and we don't want it to be that fast or else it won't be smooth. And if it's the opposite, so if it's greater than 0, it applies the opposite force. But ABS, you might think that it's useless, but what it does, it converts this variable into a positive variable, because else it will be negative, and if we apply a negative force, it's going to be right here. It's like if we removed the minus and we don't want to apply a positive force, we want to apply a negative force. So if I remove it, as you can see, we could technically remove the minus, but I think it's better if we put the minus n and IBS, because it's more clear of what we're doing. We're doing the same for the Y position. And finally, we say that final motion it equals to a vector 2, and it's motion x, as you can see, and motion y. And then we apply move and slide, so it moves by a force to the final motion. And as you can see, it works really fine. It's smooth. And if you want it to be really more responsive, you can always change that value. And as you can see, it's really responsive. So you can do what you want, and if you want it to be like really smooth, but I would not do that. But as you can see, it's really smooth. You could use that so for a spectator mode in your game if you want. I don't know, and that's kind of it. So I hope you enjoyed. I just wanted to tell you why you shouldn't use the teleportation. The problem with that is you're just doing that. I'm going to show you. You're saying position. It's equal motion. It's just that if you put that in your code, what this is going to be, it's teleporting the player to the position of the mouse. And I don't think it's a great idea because it's responsive, but it's really not smooth. It's not great. So really, I would consider using this technique if you want to have smooth movement. So if you enjoyed the tutorial, you can always leave a thumbs up and a comment. Comment if you want to say something. And I hope my English was not that bad because I'm from France and I'm really young. I'm 13. And yeah, see you guys in the next tutorial. I want to say something. I did the code by myself. I used some help on the internet for the ABS, but as I really did myself, so it's not plagiarism. So yeah, see you in the next tutorial.